Hey everyone, and welcome to this explainer. If you are an engineer, a systems architect, or really anyone working right now in the trenches of enterprise tech, this one is for you. Today we're unpacking a massive, often ignored architectural flaw. We're going to look at exactly why deploying modern AI models on top of disconnected legacy architectures inevitably leads to systemic failure. And, more importantly, we'll talk about how we actually fix it.
Okay, let's just jump right in with a pretty provocative question. Are enterprise AI agents basically set up to fail? Right now, across massive organizations, AI agents are actively being put into the driver's seat. But, there's a dirty little secret in enterprise AI right now. We're taking shiny 2026 AI tools and we're plugging them directly into 1990s data processes, legacy software, and totally siloed business logic. So, are they set up to fail, architecturally speaking? Yeah, absolutely. If they just plug into decades-old, disconnected infrastructure, failure isn't just a possibility, it is a structural guarantee.
So, here is our roadmap for today. First, we'll cover the AI context trap. Second, a navigation metaphor to make this concrete. Third, the data dependency nightmare. Fourth, we'll define context graphs. And finally, we'll build the architecture of context.
All right, let's start with part one, the AI context trap, or as I like to call it, optimizing in a vacuum. Here's the absolute bottom line. AI is literally only as effective as the context you give it. When you deploy a model, it's incredibly good at inferring patterns, right? But if it doesn't have an accurate real-time understanding of your entire system's current state, it's going to completely ignore your actual operational constraints. It's functioning in a total vacuum. It doesn't actually improve your outcomes. It just infers things based on incomplete data and, well, achieves the wrong outcomes much faster. It optimizes a tiny, localized task while remaining completely blind to the larger enterprise system.
Which brings us to part two, the navigation metaphor. We need to contrast a living system state with static data.
Think back to, say, 1995. You unfold this massive paper map to drive across town. You check the morning news for traffic, you make sure your gas tank is full, and you just drive. Now, if a road closes while you're en route, you don't know until you literally hit the barricade. And you know what? That uncertainty was totally fine in 1995. But that is exactly how legacy systems with static, decoupled databases still operate today. Fast forward to right now. You use a dynamic GPS. Your phone and your car are quietly coordinating real-time traffic, fuel levels, dynamic routing, all of it. The decisions continuously adapt because all that data is interconnected. That's the standard we expect in our daily lives, yet our enterprise systems are still largely built like that 1995 paper map.
And this brings up a quote that perfectly nails the danger here. AI without context is a faster car with a paper map. I mean, think about it. Adding a highly capable large language model to your legacy tech just gives you a faster engine. Sure, it makes your queries faster, it might generate code faster, but it utterly fails to give the system the awareness it needs to actually navigate your complex structural constraints. The car is way faster, but the driver is still completely blind to what's happening on the road ahead.
And that brings us to part three, the data dependency nightmare. This is where we move out of the metaphor and into the brutal, fragmented reality of large-scale architecture. This is exactly why so many enterprise AI pilots just hit a brick wall. Executives love these new tools that generate content or write code, but those tools only operate at the task level. Automation alone simply cannot surface the hidden business rules buried across a massive portfolio of, say, 1,000 different applications. If you've got decades of undocumented, tangled dependencies, an AI optimizing one narrow task cannot govern that deeply fragmented system. It's impossible.
Let's put a real-world number on this to make it super concrete. 27. If you go and ask a systems architect at a Fortune 500 company where the definitive definition of a customer lives in their architecture, well, in one actual case, that single seemingly simple definition existed in 27 different disconnected places.
Now let's layer some real chaos onto those 27 locations. Imagine 36 different programs are actively authorized to update that customer's state, but there are only 4 true sources of record. Just picture deploying an autonomous AI agent into that environment. If an isolated agent alters a customer record just to optimize its one specific workflow, it's going to inevitably break downstream dependencies across those other 32 programs. It has no idea what the constraints are.
So, if fragmentation is the disease, what's the cure? That's part 4, defining enterprise context graphs, the living map of the business.
So, an enterprise context graph is a living map. It exposes shared context and explicit relationships, even the ones that were never formally documented anywhere. It provides reliable reasoning about downstream impact based on how the enterprise truly operates today, not how it was originally designed to operate on some whiteboard 20 years ago. Let's be clear, this is not just another static data catalog. It is an active, highly interconnected map tracking the relationships between your data, your software, your workflows, and your business rules.
Okay, so what does this actually unlock for your engineering teams? First off, it allows you to upgrade your old tech without losing that critical, invisible logic that actually keeps the business running. Second, it shifts the whole enterprise from making opinion-based decisions to evidence-based ones. And third, and honestly, this is the most critical part for AI, it lets your AI agents work safely. It gives them the context they need to understand their full operational blast radius before they execute a single command.
All right, let's move into our final section, Part 5, the architecture of context. How do we actually build this? What's the technical blueprint?
Building a context graph starts with your first foundational layer, the ontology. An ontology is basically a structural map of things and how they explicitly relate to one another within your system. Going back to our car metaphor from earlier, the ontology is the layer that physically shows your car on the map, shows that it's physically connected to a fuel meter, and shows the destination. It maps the explicit, hard relationships of all the nodes in your enterprise.
But a structural map isn't enough on its own, right? You have to layer on semantic understanding. This is what those nodes actually mean to the business. It captures the behavioral logic. In driving terms, this is the knowledge that you, the driver, hate seeing the low fuel light, or that you actively avoid toll roads, or maybe you just prefer a reliable route over sheer speed. In an enterprise setting, this semantic layer captures all those invisible, unwritten operational rules that usually only exist inside a senior developer's head.
And this brings us to the exact three-step sequence to build out this architecture. Step 1, establish the ontology. You build that structural map. Step 2, define the semantics. You layer in the actual business meaning and logic. Step 3, integrate live data. This is where you feed in the current conditions, the live traffic, the real-time weather, or, in a business sense, your current API loads, live inventory, and the real-time system state.
Which leads us to the ultimate equation for systems architects. Ontology plus meaning plus live data equals context. This right here is the mathematical combination required to give AI true agentic capabilities. Together, this formula determines the best actual outcome for the business, not just the fastest outcome on paper. And the best part? Over time, as choices are made, this context layer actually improves and learns what matters most to your specific systems. When lead engineers and C-suite executives finally see this architecture laid out, a major realization usually hits them. They say, oh, this isn't actually about AI at all. This is about control. And they're right. Implementing a context graph is quite literally the only way to safely govern AI at scale across a massive enterprise. You just cannot realize the value of agentic AI without it. Because an agent interacting without context is just producing outputs with no systemic meaning whatsoever. The massive paradigm shift we need to make is clear. We have to stop treating enterprise AI as just a way to complete isolated tasks a little bit faster. That's a total race to the bottom. Building an enterprise context graph is really about creating the shared architectural foundation required to actually govern your entire system securely and intelligently.
I want to leave you with this final provocative thought. Ask yourself honestly, right now, if your AI agent executes a command in your architecture today, does it actually know what it just broke? If the answer is no, well, then you don't just have an AI problem, you have a context problem. It is officially time to put away the 1995 paper map and start building your living, dynamic context graph. Thanks so much for joining me on this explainer. Keep learning, keep building, and please, make sure your AI actually knows the rules of the road.